Alright, today what we're going to do is continue to write equations of lines using information, but we're going to do some tricky lines that involve thinking because we're going to be dealing with parallel, perpendicular, vertical, and horizontal lines. So we will still be writing equations needing a point and a slope, but we're going to throw some tricks in there as well using parallel, perpendicular, vertical, and horizontal. So just like normal, we're going to cover what we need to remember in previous knowledge. The title of today's lesson, Writing Equations, Parallel, Perpendicular, Vertical, and Horizontal. So the previous knowledge is, of course, writing equations, remembering how the point-slope form works. Okay, y minus y1 equals the m times x minus x1, where the first y stays y, the minus sign stays there, y1 is from the ordered pair, the slope is slope, x stays x, minus sign is from the formula, x1 is from the ordered pair. So we're going to need to remember that. We're also going to need to remember how equations should look when we are dealing with slope-intercept form, y equals mx plus b. So all that is in previous knowledge. If you still have any issues with these two as far as writing equations, just watch the previous videos on writing equations and that will help you. We need to remember from prior knowledge that parallel lines are lines that have the same slope. So parallel lines are lines that have the same slope. We also need to remember that perpendicular lines have slopes that are opposite reciprocals. Opposite meaning the signs are different, positive to negative or negative to positive. Reciprocal meaning we flip it and change the sign. Also remembering that vertical is perpendicular to horizontal. So remember that perpendicular lines have opposite reciprocal slopes. We need to remember everything we can about vertical lines. So the equation of a vertical line is something like this, x equals -4, where there is no y. If there is no y, there's no y-intercept, it's a vertical line. And also what this means is in every ordered pair on that line, the x-coordinate stays the same. So in this example, every x-coordinate is going to be -4. So any point on that vertical line, the x-coordinate is going to be -4. So we need to recall that from previous knowledge. Same thing with horizontal lines. The equation for a horizontal line, there's missing an x. There's no x. That means there's no x-intercept. That means the line is horizontal. What this means is that the y-coordinate will stay the same the whole way through on that line as a whole. So in this example, y equals 3, every ordered pair on that line is going to have a y-coordinate of -3. So we're going to need to recall that information as well. So all of that we're putting together to really do some thinking. We're going to be doing a lot of thinking in this lesson. It's one of my favorites. So we're going to put that all together to write equations of lines. Now remember that we need to have a slope and a point to write equations. For writing equations, we need two pieces of information, a slope and a point. So what we have to do is read each question carefully, because each question gives a different piece of information or different pieces of information. We need to read each question carefully and then think about the information we have and the information we need. So each question is different with different pieces of information. We have to read it carefully and think, what information do we have as far as a slope and a point, and what information do we need as far as a slope and a point. So we're going to jump right into some examples. Let's start thinking. So if we had to write the equation of a line that would be parallel to the equation y equals 1/2 x plus 2 and has a y-intercept of -3. So here is the information that we are given. Let's say we need to write the equation of the line that meets this information parallel to this line and has a y-intercept of -3. So we need to think. We have to use our brains. Remember, to write an equation, we need two pieces of information. We need a slope and we need a y-intercept. So the first thing we're going to think about is slope. We have to think about slope. What is the slope of the line that we're writing the equation of? Well, if the information we have says it is parallel to this equation, we need to think what slope is parallel to this equation. So remember that parallel means same slope. And we have to find the slope of this equation. The slope of this equation is y equals mx plus b form. The slope of this equation is 1/2. So here is our slope. That's the slope we need. So we have to think. We have to do all of this thinking. Parallel to this equation, the slope of this equation is 1/2. And since we're dealing with the same slope, the slope we need is 1/2. So the other piece of information that we have is the y-intercept is -3. So to write an equation, we now have information that we need, a slope and a y-intercept. We can now write the equation. And again, if this part is tricky for you, go back to watch the previous video of writing equations given a slope and a y-intercept. So if we're dealing with slope-intercept form, y equals mx plus b. Our slope is 1/2, our y-intercept is -3. So we have y equals, the slope is 1/2. X stays x. Plus sign stays there. The y-intercept is -3. All we have to do now is clean up this mess. Okay, so we're going to clean this up. So y equals 1/2 x plus minus is minus. And here we are, an equation in slope-intercept form. So we had to think, what was the slope we need? And what was the other information that we were given? So now, let's do something a little bit trickier, okay, involving some more steps. So the next example, what the information is, a line that passes through an ordered pair. So a line that passes through the ordered pair -2, -6, and is parallel to this equation. So we're going to write the equation of the line that fits this description. So we have to think. Remember, we need two things to write an equation, a slope and a y-intercept, or a slope and a point. We have a point. It passes through -2, -6. That is our point. But we have to think about slope. So when we think about slope, here we go again with that word parallel. So it's parallel to y equals 3x plus 1. Parallel means it has the same slope. So what we're going to do is find the slope of this line and use that as our slope. This line is in slope-intercept format. So this slope is 3. And since we're dealing with parallel, the parallel slope is also 3. So the slope we are using to write our equation is 3. See all the pieces we have to put together. We also need a point to write an equation, and we were given the point -2, -6. And now we're ready to write an equation. And if what I'm about to do is still confusing, go back to watch the other video on using point-slope form to write equations. So we're recalling we have point-slope form. Y minus y1 equals m times x minus x1. Where the y stays y, the minus sign is from the formula, y1 is from the ordered pair. The equal sign stays there. The slope is the slope that we're using, which is 3. And then we have our x that stays x, the minus sign from the formula, and then a negative 2 as the x coordinate. So we're going back to using point-slope form. Now what we do is clean up this mess before we solve for y. Remember that minus and negative is plus, and we do it again here before we use the distributive property. So now we're able to use the distributive property. 3 times x is 3x. 3 times 2 is positive 6. So all we have to do now is to solve for y. We can subtract 6 on both sides, leaving us with y equals 3x and plus 6 minus 6 cancels completely. 3x plus 0. And we can clean up this mess as well because 3x plus 0 is simply 3x. There is our equation in slope-intercept form. So we did all of this thinking. Let's go back to the original information we had. The line passed through a point was parallel to another equation. So we had to find the slope of that other equation, use that point, and go back to using point-slope form, cleaning everything up to give us our equation. So we're putting together a lot of pieces of a puzzle to answer these questions, which is why I like them so much. Let's do another example. We'll keep the examples coming. So the next example, we'll do something a little bit trickier. Here's an equation of a line, or we need the equation of a line that passes through another ordered pair. We'll say it's negative 4, 3. And this one is perpendicular to another equation. We'll say it's perpendicular to this equation. So here's the information that we are given. What we have to do with this, write the equation of a line. So we have to write the equation that fits these pieces of information. And so we need a slope and a point to write our equation. Again, we have a point, but we need a slope. So to find slope, we have to investigate what perpendicular to this equation means. So perpendicular, remember, means to find the opposite reciprocal slope. Opposite reciprocal slope. Okay, that's what perpendicular means. So we investigate the current line we have. Y equals negative 2/3 x minus 1. We recognize that it is in slope-intercept form, and so we recognize that this slope is negative 2/3. So that's the slope of the line we have. However, we need the perpendicular slope. So we have to make the opposite reciprocal of negative 2/3. So the opposite means change the sign. It's going to be positive. So we'll say the perpendicular slope is going to be positive, and then have the reciprocal of 2/3. Flip these around, and we're going to have positive 3/2. That is our perpendicular slope. So we had to think about that as well. Some good thinking taking place here. So the slope we're going to use is 3/2. The point we were given is the point we're going to use, negative 4, 3. we have a slope, we have a point, we're ready to write our equation using point-slope form. Y minus y1 equals m times x minus x1. The y stays y, the minus sign stays the minus sign. The y1 is from the ordered pair. The y1 is from the ordered pair. The equal sign is the equal sign. The slope was the perpendicular slope that we found, 3 over 2. The x stays x, the minus sign is from the formula, and the x1 is from the ordered pair. So now that we have this written down, we're ready to clean it up. So let's clean up this mess before we start using distributive property. We have y minus 3 equals 3 halves times x plus 4. And if this is confusing, go back to watch point-slope form of writing equations. So now we're ready to use the distributive property. Y minus 3 is equal to 3 halves times x. 3 halves times x is 3 halves x. And now we have 3 halves times 4. So 3 over 2 times a positive 4. And a 3 over 2 times a positive 4 is a positive 12 over 2. And so we can clean this up. And we continue cleaning. So we have y minus 3 is equal to 3 over 2x plus 12 divided by 2 is 6. Oh, I forgot the minus 3. So don't forget the minus 3. Y minus 3. That's still a y minus 3. We have to get y by itself, so we add 3 to both sides. And so we'll have y equals 3 halves x plus 6 plus 3 is plus 9. And there is our equation. Look at all these steps to take, all the thinking and all the algebra. Love it. We start with passing through a point perpendicular to another equation. We have to think about this perpendicular to establish our slope. We have the slope of the given equation. We have our perpendicular slope, which is the slope we're going to use. We have our point. And then we use point slope, clean it up. Don't forget the minus 3. And then solve for y. Here is our equation. All of those steps that have to be taken to write our equation. So now we'll do a few more examples for vertical and horizontal lines. So now we're going to remember what vertical and horizontal lines were like. Okay, vertical lines are lines that have no y in the equation. So let's do a recap of the notes. Vertical lines are lines that have no y in the equation. The value of the x, okay, the value of the x depends on the ordered pair. So what that means is, if there is a vertical line that's passing through this ordered pair, the equation has no y, it's just x equals something. The equation depends on the value of the x in the ordered pair. So in this example, x equals the x coordinate in the ordered pair. So vertical means no y. The x value is the x coordinate. X equals 3 is this equation. So that's how vertical lines work. For horizontal lines, the equation has no x. So the value of y depends on the ordered pair. Here's an example. If we have a horizontal line passing through -4, -1, the equation since it's a horizontal line, the equation will have no x. It's going to be y equals something, but it depends on the ordered pair. So it's y equals something. Horizontal means that there is no x. The y value in the equation is the y coordinate. So in this example, a horizontal line, simply y equals the y coordinate. Y equals -1. That is the equation. So this is some neat thinking that's taking place for vertical and horizontal lines. So let's see a few examples. Let's write the equation of the line passing through an ordered pair. In this case, -6, -3. Here's the first piece of information we're dealing with. It's passing through an ordered pair, -6, -3, and it is perpendicular to this equation. There is a lot of thinking that has to take place here. It's passing through this ordered pair. It's perpendicular to this equation. We have to think. So now we're thinking. Perpendicular to y equals 7. Well, let's think about y equals 7. First of all, let's think about y equals 7. What kind of line is y equals 7? There's no x. It is a horizontal line. So we have to think that. We have to remember y equals 7 is a horizontal line. And what is perpendicular to horizontal? Perpendicular to horizontal is vertical. All of the thinking that has to take place. So now what we need is a vertical line going through -6, -3. So we're dealing with a vertical line through -6, -3. So now we continue our thinking. Vertical line. A vertical line means the equation has no y. So the equation is going to be x equals something, and the value of x depends on the x coordinate of the ordered pair. The x coordinate is -6, so there's our equation. X equals -6. That is our equation. So let's go back to the problem we started with. A line that's passing through this ordered pair, but it's perpendicular to y equals 7. We have to think. Y equals 7 is a horizontal line. Perpendicular to horizontal is vertical. So we need a vertical line through -6, -3. That means there's no y in the equation. It's just x equals -6. There is a lot of thinking that has to take place. I'm sure you can do well with it, because that's the whole purpose of algebra in the first place, is to exercise your brain. I wish you luck, and I'll see you in class.